All right, we're down to the last half of the course. You guys should have just completed your Module 2 test on Chapters 6 and 7. Module 3 consists of Chapters 9 and 10. Believe it or not, I think that this course gets easier as it goes along. I think that the most challenging test was Test 1, and then the second most challenging test was the one you just had, and this one is easier, and then the final is even easier. So if you're staying above water, you're doing good. Chapter 9 is forecasting, and if I had to tell you what made me, or what one of the keys to my success was in managing operations, it was my ability to forecast revenue and costs. This is an essential tool in being successful in managing businesses and profit and loss statements and all those good things. So what is defined as forecasting is defined as using historical data to predict future events. And there's three different types of patterns of data, and this is in your textbook. We've got trend, seasonal, and cyclical. And I like to start with cyclical and then work my way down. We've got business cycles. They say that election years are usually the peak of business cycles in the United States, and that's because of how much money the candidates, the presidential candidates, spend on getting your votes. So we have business cycles, bull and bear markets and things like that, recessions and booms, and right now things are picking up. They say that everybody should be getting raises this year, that unemployment is now down around 6.5% as opposed to being 11% as it was around 2008. Things are getting much better. And then on top of that, we have seasonal changes. And, and if we were to look at Oxford as an example, the slowest month in Oxford is always December and the first couple weeks in January. When all the students are gone, that's the time if you want to eat in any of the restaurants, you can get it anytime you want, Monday through Saturday or Monday through Sunday. And then, of course, the busiest time in this market is during football season, and especially during home games. So we definitely have a seasonal market. Some restaurants are busier during the day, like a McAllister's or a Nuke's, and then others are busier at night, like the restaurants again on the square. Some restaurants are busier Monday through Friday than they are on the weekends. Most restaurants, though, are busiest Thursday through Sunday. And then if we look at hotels, we've got transient hotels that have Sunday through Thursday business where people are traveling on business. And then we've got the other hotels, the non-transient hotels or resort hotels that are going to be busiest Thursday through Saturday again. And then trend is when we actually go ahead and draw a line through our cyclical and seasonal and historical data, and we have a trend line. It's usually either an upward trend, a downward trend, or a level trend. Hopefully it's an upward trend. And I'm going to ask you some multiple choice questions on the pattern of data, or these three types of data and what they mean. Or I'm going to give you examples of them, and you'll have to tell me which ones they are, so you'll want to research those in the text again. Okay, so as far as forecasting methods, the first one is the simplest one to do, and it's the naive method. And if we have no basis to determine what our sales are going to be next year, let's say it's our first year of business, or let's say that we're even planning on putting together financials for an SBA loan, a small business loan, and we really have no idea what our sales are going to do. We're just going to use a percent increase to forecast our sales. So in year one, let's say that we project $120,000 and we anticipate our sales to increase by 10% a year. Well, if we multiply $120,000 by 1.10, we get $132,000. For some reason, that 1.10 confuses a lot of students. Students want to multiply 120,000 by 10%, 0.10, and get $12,000, and then add it to $120,000 and get $132,000. But if you look at the math of 1.10, any number multiplied by 1 is itself, so you get 120, and then the 0.10 is the 12, so mathematically you're doing the same thing without the extra steps. And then we have moving averages. What moving averages do is they, first of all, they assume that the most recent weeks are the most relevant, and that eventually weeks or periods or days become irrelevant. So we add weeks and knock weeks off of our average. So as an example, if we look at this 1 through 5 and that we're doing a 3-week moving average, we're going to go ahead and take weeks 3, 4, and 5, and we're going to average those numbers, and we get 2,600. If we have a week 6, then we're going to knock off week 3, and we're going to use 4, 5, and 6. And we just keep on knocking off one week or one number and adding another number. And in doing so, we're always using our most recent periods. If we are set on using moving average and we're not getting great numbers using a 3-week moving average, then we want to go ahead and increase our weeks. The more weeks we have, the more relevant information we have. If you look at this example, week 3 is our lowest week. So if we were to do a 5-week moving average, it would kind of cut out that week or minimize that week. So we could actually go ahead and increase this to a 5-week moving average if we wanted to get a more detailed forecast. And then we have weighted average. Weighted average is not in the book, okay? But weighted average is a very common way of forecasting, and it goes by the same premise of moving average, that the most recent week is the most relevant. And I guess I should have put these weeks the opposite way and made the weight of 0.5 on week 3 and then the 0.2 on week 1. We need to go ahead and weight our weeks as the most recent one is the most relevant. So what I would do on the test, because that's what you all want to know, is I would have to give you the weeks and the weights and have you determine the forecast. So in this example, all we're doing is we're just multiplying our numbers. Our data is our sales, so we take 0.5 times $1,000 in the most recent week and we get 500. 0.3 multiplied by 800, which is the intermediate week, and we get 240. And then finally 0.2 times 900, we get 180, and we add those up, and that's our forecast. You need to make sure that if you're doing Mondays, that you're comparing Mondays to Mondays. If you're doing days of the week, rather, that you use your Monday numbers to forecast Mondays and Tuesday numbers to forecast Tuesdays. And if you're doing months, you want to go ahead and use your January to forecast January and February to forecast February, and so on. And I'll give you sample problems on chapter 5 and 6 or a study guide, and in that we'll have a weighted average for you to review this. Okay, then we have exponential smoothing. And exponential smoothing is actually a method that I've never used, but it makes a lot of sense. And what it does is it smooths out lows and highs, and if you only have a little bit of data to forecast with, it's a real good way to go ahead and get some pretty clean forecasts. So the first thing you do is you go ahead and you calculate your smoothing constant, and that's period 2 forecast minus period 1 forecast divided by period 1 actual minus period 1 forecast. So of course you're going to go ahead and do your math on the top, do your math on the bottom, and then divide. And then we have the forecast, and we take our past forecast, we add the summation of our smoothing constant multiplied by actual demand minus past forecast. So like I said, this will help us with seasonal variations, but it's also good if we don't have a whole lot of data. If we have no data, of course, we're going to use the naive method because we don't even have a past forecast to past actuals. But if we've got a little bit of data, we could use smoothing constant and actually get some pretty good forecasts. So here's an example. We've got week 1 and 2, we've got the forecast and the actual. And so the first thing we do is we calculate our smoothing constant, and we take our Week 2, we subtract it from week 1 forecast, and then we take our actual demand and subtract it from our week 1 forecast, and we get a 0.7. So our smoothing constant is a 0.7. That number can actually be negative. If our sales are declining when we do this, we're going to get a negative number. In this example, we have a 0.7 as our smoothing constant. Then we just plug the smoothing constant into our formula, and we get a new forecast of $6,310. As I told you before, I'm going to supply you with a formula sheet on chapters 6 and 7, and this is one of the formulas, or these are two of the formulas that I'll be giving you. So what you need to do is just understand how to do the math and how to plug in the smoothing constant and such, and that's the reason why I provided you with examples, so you can do what's in the parentheses first and then add it to the $1,600 as the example at the bottom, and get used to doing the math. Okay, and finally we've got qualitative techniques, and I'm not going to go over these, but you'll need to know these different types of techniques and what they entail, and there will be test questions on them. So I did list the 4 that the book talks about, so that way you could go ahead and go into the test and review them, and make sure you study these for the test. Like I said, I'm not going to spend a whole lot of time on them because they are in the book, and you guys are capable of researching them yourselves. And that's the end of the material for Module 3.